Good afternoon, children. And today we are going to start with the DF block PYQs for NEET. Okay, so let us begin without any further delay. And there will be some questions displayed on your screen, and you have to, as you know, you have to pause it and try them by yourself. Okay, so let us begin, children. So the first question on your screen, everyone try. Okay, so let us see what is given here. It's given that there are two statements. Okay, one is assertion and other is reason. So the first question that is being asked here is, the ionization enthalpy increases along each series of the transition element from left to right. How a small variation occurs, right? So we know that we have 3D series, 4D series, 5D series, and 6D series, right? Okay, so these are the series. Now, what happens in each series? We know that when we move across a period, our ionization enthalpy increases, right? So here also it is telling that in case of transition elements, as you know, the transition elements are from group 3 to 12, right? We all know this. So in case of these elements, when we are moving from left to right, here also the ionization energy is increasing, but not much. A very meager amount, a very small amount of change you can observe. And why is that so? That is because in all these series, the D blocks are gradually getting filled. Yes, the D blocks are gradually getting filled. As you know that D orbitals are big orbitals, right? Okay, large orbitals. And their shielding is very low. Their shielding is very low. And because of very less shielding, as there is very less shielding, we can see that their ionization enthalpy, what happens, children? It increases, but how much it should increase? It doesn't increase that much, but very less variation we can see, right? Okay. So is the same reason given there? There is a corresponding increase in nuclear charge which accompanies the filling of electrons in the inner d orbital. So as these d orbitals are getting filled, so we know that their shielding is very less, and that's why these things are happening, right? So can I say that assertion and reason both are correct, and R is the correct explanation of A. R is the correct explanation of A. So are we clear with all of these, children? Yes. Moving on to the next question. Next question on your screen. Another assertion reasoning. Try, everyone. Okay. So children, here it is telling that the ionization enthalpy of early actinoids are lower than that of early lanthanoids, because the 5f orbitals experience greater shielding from the nuclear charge. Is it correct, children? Yes, we know that these both are correct. So it is a kind of related one. Yes, similar type. So we'll go on to the next question. Okay. This is important. Okay. All these questions are directly from NCERT and they're the previous year question. This is asked in NEET 2022, I guess. Okay. So the question is, the stability of Cu2 plus is more than Cu2 plus in Cu plus in aqueous solution, right? So just try it once. What could be the answer, children? Okay, children. So we'll see what happens exactly here. We'll see the electronic configuration, the ground state electronic configuration. Yes, we'll see the ground state electronic configuration of copper. So we know that it is argon 18. Yes, 4s1, 3d9, 3d10. Right? Okay, this is the ground state electronic configuration. If we see the configuration of Cu plus, what are we going to get? We are going to get argon 3d10. And as we can see here, the D10 configuration is very stable. Yes, your D10 configuration, children, that is very stable. Yes. Okay. Now let us talk about Cu2 plus. Talking about Cu2 plus, we are going to have 3d9. We are removing the electron from the very stable electronic configuration. Now, but this is written in aqueous solution. In aqueous solution, what happens, children? We know that the size of Cu plus is greater than the size of Cu2 plus, right? Yes, why? Because when the plus charge increase, the cationic size, they decrease, right? Okay, so when they are in aqueous solution, children, water molecules are going to surround them. Water molecules are going to surround them. Here also water molecules are going to surround. Yes. Now, when this water molecule surrounds Cu plus and Cu2 plus, some kind of energy is liberated. And what is that energy, children? That is called as hydration energy. That is called as hydration energy, right? Now what happens, children? When the ion is smaller, so we know that more water is going to surround. You can think of it that way. There is a smaller dot here, there is a larger dot here. So obviously here less number of water molecules and here more number of water molecules are going to surround. That means more hydration energy is being liberated here. Liberated. So can I say that this is negative hydration enthalpy? This is negative hydration enthalpy. This is, we are getting this much amount of energy. Now, when you removed Cu to Cu2 plus, the ionization enthalpy was E1. Yes. When you did from Cu to Cu2 plus, the ionization enthalpy was E2, right? Suppose you say that here you invested 400 kilocal of energy, here you invested 500 kilocal of energy, and here you got minus 2000 kilocal of energy. Now you see, children, we know that 400, 500, so we use so much amount of energy here, right? So much amount. So say it, this one be 900. Okay, so then also you see how much energy is liberating. Minus 2000 energy is suppose being liberated, so it is compensating for whatever energy we are giving here, extra energy that is required to remove the E2 plus or the E2 in order to remove the second electron. Whatever ionization energy we are giving, that is being compensated by the very high negative hydration enthalpy. Why? Because Cu2 plus being smaller in size, the hydration enthalpy is very large, right? So it heavily compensates, because here you are 900 you are giving, but here 2000 you are getting, right? So that is compensating for the energy of ionization, right? So what is going to be the answer, children? Your answer is going to be hydration energy. Your answer is going to be hydration energy. Clear, everyone? Okay, let us go to the next question. Again, statement 1 and statement 2. Careful, okay? Okay, children. So let us see here. We'll look at the statements that are given below. So two statements are given to us. Statement 1 says that Cr2 plus is oxidizing, Mn3 plus is reducing. Statement 2 says that scandium 3 plus compounds are repelled by the magnetic field. They are repelled by the magnetic field. So we'll look at this second statement first. So the scandium is 21, right? This 21. So I can write this argon 18, yes, 4s2, 3d1. So if I'm writing sc3 plus, so I'll have to remove 2 from here, 1 from here. So you're going to get argon 8. So can I say that there is no unpaired electrons? Okay, so all these are paired, right? Here it is, everything is paired. So obviously when your magnetic field is coming, when your magnetic field is approaching, there will be a lot of repulsion. Yeah, there will be a lot of repulsion. So can I say that statement 2 is correct? Statement 2 is correct, right? So wherever you see that statement 2 is incorrect, so here statement 2 is incorrect, here statement 2 is incorrect. So this is going to be false. This is not going to be your answer, right? So let us look at statement 1, what is given in statement 1. Statement 1 says that Cr2 plus is oxidizing. That means it should undergo reduction, but this statement is wrong. This should be reducing and this should be oxidizing. Why is that? So we'll see. How did I tell you like that without doing anything? So we'll see their electronic configuration. Looking at the electronic configuration of chromium, children, chromium is 24, argon 18, 4s1, 3d5. Okay, if you are having Cr2 plus, Cr2 plus is going to give you 3d4. We know that 3d3, okay, 3d3, okay. If it is reducing, it is going to undergo itself, it's going to undergo oxidation, right? So when it undergoes oxidation, it is going to have 3d3, which is very stable. Why is 3d3 very stable? Because we know that we have T2G, T2G, T2G is half filled. So 3d3 very stable because this is half filled, right? So when it is 3d4 to 3d3 more stable, so it is undergoing oxidation. That's why it should be reducing, but here it is written oxidizing, so this is wrong, right? Let's look at the other one. Other one is Mn3 plus, children. Other one is Mn3 plus. So we know that manganese is argon 18, 4s2, 3d5. So Mn3 plus, if you remove 3 electrons, okay, if you remove 3 electrons, it's going to be 3d4. It would want to be 3d5. It would want to be 3d5. That means it is going to gain. This is going to gain, right? When it is going to gain, that means this should be oxidizing. Then only it will undergo reduction to gain. So when it is 3d5, it is undergoing reduction. Reduction means it should be oxidizing in nature, right? So that's why the first statement is wrong. Yeah, the first statement is incorrect, whereas the second statement is okay. So the second statement is correct. Just a minute, children. Okay, the first statement is incorrect and the second statement is correct. This one is also wrong. So what is going to be your correct answer, children? Your correct answer is going to be statement 1 is incorrect, whereas statement 2 is correct, right? So a lot to do with the electronic configuration, right? Okay. Next question on your screen, children. Try. Okay, let's see, children. So which one of the following is incorrect? The incorrect statement among the following is being asked to us, right? So let us see. Actinoids are highly reactive metals, especially when finely divided. So what happens, children, when you divide something, when you break down something, then what happens? The surface area increases. The surface area increases. And we know that when the surface area increases, children, then what happens to the reactivity is directly proportional to reactivity. Yes, so your reactivity is also going to increase. So can I say that the first statement is correct? Definitely. Actinoids are highly reactive metals, especially when finely divided. So this statement is correct. Okay. Actinoid contraction is greater for element to element than lanthanoid contraction. Now what this statement? We know that here 5F is in the filling process in case of actinoid. In case of lanthanoid, 4F is in the filling process. Right? Okay, so can I say that this has more what? Shield, right? This has more shield, this is less shielded. So what happens? Nuclear charge increases. Yeah, as nuclear charge increases, so the electrons are going to get pulled towards the nucleus. When electrons get more pulled towards the nucleus, so can I say that actinoid contraction is greater than lanthanoid contraction? So this statement is also correct, right? So most of the trivalent lanthanoids are colorless. Are they colorless? No, they will have unpaired F electrons as well. They are going to have unpaired F electrons as well. So when there are F electrons, they are causing your lanthanoids to be colored, right? So this statement, children, is wrong. Yes. Nevertheless, we are going to see the last statement also. Lanthanoids are good conductors of heat and electricity. This is also correct. Yes. So which one is the wrong one, children? The wrong one, the incorrect one is going to be your option C. The incorrect one is going to be option C. Any doubt till here, children? Next question on your screen. Easy one. Okay. And this was asked, I guess, in 2020 maybe. Yes. So such type of questions are also asked. Try this. Okay, children. So let's see what's given here. Which of the following reaction is a metal displacement reaction? Choose the correct option. So it's being told here that which one out of these is your correct option, right? So let us see. So we see that here PbNO3 whole twice gives rise to this. So can you directly see that this reaction, children, is a decomposition reaction? What reaction? Decomposition reaction. Yes. Okay. Now, looking at this reaction, children, again heat is given in this. We are getting two products from one. So this again is going to be your decomposition reaction. Now, the last one we see that this is what, children? Reaction of metal with acid. But this reaction, if you see here, there are two elements, it is chromium and aluminium, and your aluminium has replaced chromium from its solution. That's why this will be metal displacement reaction. Okay. Yes or no, children? That's why this will be called as your metal displacement reaction. So this one is going to be your metal displacement reaction. Yes, children? Okay. So next question on your screen, everyone. Yeah. Try easy one. Okay, children. So what's given here? What is given here, children? It's given here that you are having zirconium and hafnium. What do you have? Zirconium and hafnium, right? So zirconium atomic number 40 and hafnium 72. So it is asking us that why do they have similar atomic and ionic radii? Okay, is it because they have similar chemical properties? There is no link as such. They belong to the same group. No link like that. Diagonal relationship? No. Yes. Then lanthanoid contraction. This is going to be your answer, right? So we know that a major consequence of your lanthanoid contraction, a major consequence of your lanthanoid contraction is the similarity between atomic and ionic radii. The similarity between atomic and ionic radii, that's why you are going to have that lanthanoid contraction causes similarity in the radius, right? So hafnium is a post-lanthanoid element, so it has 4f orbitals, right? And as we know that D and F, their shielding is very, very less. Yes, so here they have poor shielding. The effective nuclear charge on valence shell is more, which results in decrease in the size of hafnium, right? So here we know that it is a post-lanthanoid element, and then it has having 4f. 4f shielding is very less, because of that the size is less. This effect is known as obviously lanthanoid contraction. Similarly, zirconium and hafnium will have a similar radii because of lanthanoid contraction, right? Clear, children? Okay. Okay. Try this one. Okay, so let us see what is given here in this question. The question here is identify the incorrect statement. You have to find which statement is incorrect, right? The transition metal and their compounds are known for their catalytic activity due to the ability to adopt multiple oxidation state and to form complexes. This statement is correct, children, right? We know that as they can adopt multiple oxidation state, they are behaving as catalyst, and when they behave as catalyst, they help to lower down the activation energy, right? And when the energy of activation is lowered, they can easily cross the energy barrier. Yes, children, that is what happens in case of your actinoids. Then we know that as their size is small, right? So because of that size, this hydrogen, carbon, nitrogen, they are your known as interstitial compounds, because inside the crystal lattices of these metals, these small atoms, they go and fit in the size of the void. So like whatever crystal lattice you're having, the size of, okay, the size of void that is being created here, your hydrogen, carbon, nitrogen, they can go and fit here. They can go and fit here. That's why they are called as your interstitial compounds. They are called as your interstitial compounds. Yes or no, children? Okay, so this statement is also correct. This statement is also correct. Now, the oxidation state of chromium in this, and this is not same. Let us find out. So this is X plus 4 oxygen. Each oxygen has a charge of -2 is equal to -2, which implies X minus 8 equals to -2, which implies X equals to -2 plus 8, that is equal to +6. So in here it is +6, right? Checking for the other one, this is 2 chromium, so 2x plus 7 oxygen. Each oxygen has a charge of -2 is equal to -2, which implies 2x minus 14 equals to -2, which implies 2x equals to 12, which implies x equals to +6. So here we see, children, and that is also +6. There's a +6 and that is also +6, right? Okay. So that's why we can say, children, that what can we say? It is same, but here it is given not same. So this one, children, is your incorrect statement. This statement is going to be the incorrect statement. Yes. Okay. Next thing. Okay. We are going to discuss the last also. It is saying Cr2 plus D4 is a stronger reducing agent as compared to Fe2 plus in water. We'll analyze this statement. Okay. We'll see the correct answer first. The incorrect statement is this one. Yes. This is your incorrect statement, but we'll analyze the last statement also. It is given that Cr2 plus, talking about Cr2 plus, and also we are talking about Fe2 plus. Okay, so writing the electronic configuration, this is argon 18, yes, 4s1, 3d5. Now this will become, in case of Cr2 plus, it is going to be 3d4. Yes, this was 4s2, 3d6. So this will become 3d6, right? Yes. Okay. Now, children, what happens when they undergo oxidation? When they undergo oxidation, they're saying stronger reducing agent. Reducing agent means what, children? They will undergo oxidation. They will undergo oxidation. So when it undergoes oxidation, this is going to be 3d3. This one is going to be 3d5. So here we are getting a more stable T2G. Here we are getting a more stable T2G. That's why we are telling that this is going to be your stronger reducing agent, right? Yes, this is going to be a stronger reducing agent. Yes, so further also we can decrease little bit from here, but from here it's like difficult. From here it is difficult. Okay, from 3d3 you can make 3d2 1. Okay, but from here making it's going to be difficult. That's why we say that this is a stronger reducing agent. Although this is a T2G stable and this is D5 stable, but from here we can remove a little bit easily as compared to this, right? Okay. Next. Try, children. Okay, children, let us see what is given here in the question. The question has asked us which one of the following has a DD transition and paramagnetism as well. We know that for both of these we require one thing, that is unpaired electron, right? Paramagnetism means it is attracted towards the magnetic field. Diamagnetism means repelled by the magnetic field, right? Okay. DD transition means what, children? Suppose we have T2G and EG above. right? So if one electron is jumping from T to G to EG, right, that is going to be called as a DD transition. And because of DD transition, we see colors. How? When it absorbs energy, it goes up, but it cannot stay there for a longer time, so it tries to come back to its home, so it releases energy. It releases energy. When the energy is released, it is seen as a color. Yes, it is seen as a color, right? Okay. So we'll see in which of the following cases we'll have unpaired electrons. So we'll check for all the cases. Yes, children? Okay. So let us see the first case. First of all, I'll find out all the oxidation state. This is X minus 8 equals to minus 2. I'm not going to tell you everything that how is it done. You of course know. I'll just write down one here, X plus 4 into minus 2 equals to 2. That is how we got, right? Okay. So this implies X equals to plus 6 here. Now looking at this one, this is 2x minus 14 equals to minus 2, which implies 2x equals to 12, which implies x equals to plus 6. So here also chromium. So this cannot be the answer, right? Because both are plus 6. Obviously both are not given in the option, in a single option. So these are not going to be the answer, right? So x minus 8 equals to minus 1, which implies x equals to plus 7. Here if we see x minus 8 equals to minus 2, which implies x equals to plus 6. Okay. If you know the electronic configuration of chromium, children, this is going to be argon 18 for chromium, right? 4s1 3d5. Looking at the configuration of manganese, it is argon 18 4s2 3d5. Yes, in the first two cases we have to remove 6 electrons. What, children? In the first two cases we have to remove 6 electrons, right? So from here 1, here 5, 6 electrons. So plus 6 will give you 0 unpaired electrons. 0 unpaired electrons. So this is not going to exhibit DD transition or paramagnetism. This both are cancelled. Looking at this one, if you remove 7 electrons, this is going to be plus 7. So again 0 unpaired electrons. So this is also not going to be your answer. But if you remove 6 electrons, so 2 from here and 4 from here, you are going to get 3D1 configuration. You are going to get 3D1 configuration. So when you get 3D1 configuration, children, you will also see DD transition and you are also going to see paramagnetism. You are going to see DD transition as well as paramagnetism. So which one is going to be your correct answer, children? Your answer is going to be option D. Yes, your answer is going to be option D. Yes, moving on to the next question then. Okay, next question on your screen. Everyone pause and try. Okay, children. So I haven't given any options here, okay, so that you try it by yourself properly. It's given spin magnetic moment, right? Okay. So spin magnetic moment has a symbol of mu, which has the formula root over of n into n plus 2 with Bohr magnetism. This is your Bohr magnet. Where n, children, is the number of unpaired electrons. So we have to match them, right? So let us find out then. Cobalt, we know that. Okay, so this is 26, Piconi 27 and 28, right? So this is 4s2 3d6 4s2 3d7, 4s2 3d8, chromium 4s1 3d5, right? Something like this. I'm not writing the argon part. So if I want to remove 3 electrons from chromium, removing 3 electrons from chromium, it is going to give you 3d6. Cr3 plus, removing 3 from here, so it is going to give you 2 from here, so 3d3. Again nickel Fe is 3 plus, so 2 from here, 1 from here, so 3d5. Ni2 plus, so 2 from here, so this is going to give you 3d8. Okay, this is the D configuration that we found out. But are we just to find out the D configuration? No, because N is the number of unpaired electrons, children, right? So I hope you know how to find out the unpaired electron, making it like this. Yeah, just to show you, I'm showing that you have to calculate this. You can do in mind as well. Takes hardly 10 seconds. So 5 means everything unpaired. So N equals to 5 here. 6 means 1 will be paired. So N equals to 4 here. 8 means 3 will be paired. So 2 remaining. So 2 here, right? Now 3 means N is equal to 3 here, right? So if we find out the mu here, this is going to be root over of 5 into 5 plus 2. That is root over of 35. So the cobalt Fe is 35, right? So Fe3 plus is going to be 35. So we'll make boxes here. Fe is 35. Then going for the next one, here it is cobalt is 6. So 4 into 4 plus 2 root over. So 4 into 6, this is going to be root 24. So root 24. Which one is root 24, children? Your cobalt is root 24. So this is going to be root 24. Right? The next one. The next one is for chromium. Chromium has 2. Right? Yes. Sorry, nickel is 2. So 2 into 4. This is root 8, children. So chromium is root 8. So nickel is root 8. So nickel is root 8. And the last one remaining. Which one? Chromium N equals to 3. 3 into 5. Okay. So this is going to be root over of 15. Which one, children? The last one. This is 15. This is also going to be 15. Right. So that is how you could have matched. Yes. Yes, children. Okay. So can we say we got everything? Yes. All the things we got here. The how you understood how to find out the spin magnetic moment. Okay. Yes. Moving on to the next question. Next question on your screen and try. Okay, children. So what is going to be the answer? It's a direct question. What is the question? If you were not able to see the entire question, the question here is telling that we have HgCl2 and I2 when they are both dissolved in water containing I minus ions. Okay. So what species are formed? So I2 and I minus will give you I3 minus. So this is cancelled. Obviously HgCl2 and I minus, this is going to give you HgI4, right? This is a stable, more stable one. Yes. So your answer is going to be option B. How? We saw, right? Like whenever there is your I2 it reacts with I minus. So this is going to give you I3 minus. And HgCl2, when it reacts with I minus, it gives you HgI4 minus. It's a basic reaction, right? So which is going to be your correct answer? B is going to be your correct answer. Yes, children? Okay. Next question on your screen, and it's a very old question, but a good concept is there here. Just try. So name the gas that can readily decolorize acidified KMnO4 solution. So you have to find out which gas is going to decolorize KMnO4 solution. How are you going to know that which gas is going to decolorize this one? You're going to know when you see the oxidation state of all these elements. When you're going to see oxidation state. How, children? Why are we going to see the oxidation state, children? It is because we know that KMnO4 is a very strong oxidizing agent. Yes, it is a very strong oxidizing agent. So the one that is going to react very much with KMnO4 is going to decolorize it, right? You know that KMnO4 is a very strong oxidizing agent. So that species which will react more is going to decolorize. That is going to decolorize. And which species is going to react more? That one which has a tendency of going higher oxidation, tendency to go oxidation, right? So that one which has a tendency to undergo oxidation. So which one has a tendency to undergo oxidation? The one which hasn't reached its maximum oxidation state, right? Hasn't reached its maximum oxidation state. Yes, for example, for nitrogen, if you see, this is x minus 4 equals to 0. This is plus 4. It has reached already, right? Okay. Now for phosphorus, 2x minus 10 equals to 0. 2x equals to 10, which implies x equals to plus 5. So this has also already reached, right? So this is not going to get oxidized, children, right? Now this again, x minus 4 equals to 0, which implies x equals to plus 4. So this has also already reached. This has also already reached. So this is also not going to show. This is also not going to show, right? So which one is going to show then, children? SO2 is going to show. If you see, this is x minus 4 is equal to 0, which implies x equal to plus 4. And we know that for sulfur, the maximum oxidation state is plus 6. That means it can change from plus 4 to plus 6. Okay, as it can change from plus 4 to plus 6, it is going to get oxidized. Yes, so it will become SO4 2 minus. From SO2 it is going to change into SO4 2 minus. Now we see that this is going to be your x. This is minus 8 equals to minus 2, which implies x equals to plus 6. So this is going to change. As this is going to change, so this is going to decolorize. Yes or no, children? So that is going to be your answer. Yes, this one is going to be your answer, which is option A. Yes, good question. Okay, now try this, children. Okay. So let us see what is given here. The reason for greater range of oxidation state in actinoids. We know that the chemistry of actinoids is very difficult to study, right? The chemistry of actinoids, it is very difficult to study. Why? Because they have a large oxidation state. They have a large number of oxidation state. Yes or no, children? And what attributes to this large number of oxidation state is the 5f, 6t and 7s having comparable energies. So when they have comparable energies, children, you can shift the electrons. You can shift the electrons and you can create a whole lot of oxidation state. You can create a whole lot of oxidation state. Right, children? So did you understand? So here it's given only 4F and 5D. So no, this is not that one. The radioactive nature of no, not this one. Radioactive nature is one of the reason why the chemistry of actinoids is very difficult to study, right? Yes. Actinoid contraction, no. So the only probable reason that you can see here is 5F, 6T and 7S. Yes, children? Okay. So that is going to be your answer. And this was the last question as well. Okay, so as you can see, you are going to get questions mostly from your lanthanoid and actinoid contraction. You're also going to get questions, children, from your electronic configuration. What electronic configuration? So do pay attention to this. Okay, so what's the trend that is clear now is that you'll get questions from electronic configuration and you're going to get from actinoids and lanthanoids as well. So just see their electronic configuration very thoroughly. You are going to get direct questions this time expected. Yeah, so just look at that. Okay, so with this we'll end our lecture here. Okay, so we'll see you in another class with some more concepts and strategies and question. Okay, so until then, take care, children, and bye bye.